Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for doing zigzag level order traversal on a binary tree. Let's look at the problem description. We are given a root of a binary tree and we have to return the zigzag level order traversal of its nodes value. We have to go left to right, right to left, left to right. So if you see here 3, 20, 9 and 15, 7. The constraint is the tree the number of nodes in the trees 0 to 2000 and the node values will be -100 to 100. Let's see how we can do the zigzag level order traversal for this input. So this approach is a little bit modified version of the regular level order traversal. So in this case what we do is we maintain a boolean variable flip and that is initialized to false. So when we do first level order traversal, we first see only node 1 and then after this level is processed we added this node to the output list. So once that level processing is done, after coming out of that inner loop, what we do is we toggle that flip boolean variable so that becomes true. So in the second level is processed, whenever the flip variable is true, this current level list will be reversed and then added to the output list. After done that, then again we toggle that flip variable. Now that becomes false. So when we see when we process this level and then come out of that inner loop, we see that false. We simply add that list, current level list as it is. So whenever the flip is false, we add that current level list as it is. Whenever the flip is true, we reverse that current level list and then add it to the final out list. That is the logic here. Let's look at the flowchart. Input for this procedure is the pointer to the root node. First we initialize the out list and then the boolean variable flip. Then we check whether the root is null. If so, we go out and return the empty list. Otherwise, we initialize the queue and then add the root node to that queue. Then the outer loop begins here. First we check whether the queue is empty. If it is empty, we go out and return the out list. Otherwise, we prepare the data structures for processing the current level element. So basically we initialize the current level list, count, index, all these things we initialize and then we enter the inner loop. So this will process the count number of nodes in the queue. So first it will dequeue the first element and then add the value of that element to the cur level list. Then it will check whether that element has a left child. Then it will add that left child to the queue. If it has the right child, it will add that right child to the queue. It will continue until it processes the count number of elements in the queue. So once it processes all the elements, it will come out of the loop. Once we come out of the inner loop, first thing we check is whether the flip boolean variable is true. If so, we will reverse that cur level list. Otherwise, we simply add that cur level list to the out list. Then we toggle the boolean value so that the next level will be in the reverse order. So by doing that, in the first iteration, the flip is false. So we go left to right. Second time, flip is true. So we display the elements from right to left. Third times, it will be flipped back to false. So it will be shown left to right. So finally, Once the queue is empty, that means we processed all the nodes in the tree. So we come out of the outer loop and then we return the out list. Let's move on to coding. First I initialize the out list. Then I check whether the root is null. If so, we return the empty list. Then I initialize the queue with root node in it. And then the flip boolean is initialized to false. Then we are entering the outer loop. So there we check whether the queue length is greater than 0. If so, then we enter the loop, and then first thing we do, take the count, the number of elements in the queue, and then cur level list. Then in the inner for loop we process the count number of elements in the queue. First we dequeue the first element, then add that value to the cur level list. Okay, updating the queue, and then add the cur node's value to the cur level list. Then I check whether there is a left child and also the right child. If so, then I add both the left and the right child to the queue. After processing the count elements, we come back to the outer for loop, and there the flip variable is checked whether it is true. If so, the cur level list will be reversed. Otherwise it is used as it is, and that cur level list will be added to the out list. Then the flip boolean is toggled. Finally, after processing all the elements in the tree, nodes in the tree, we return the out list. Now I am writing the reverse function to reverse the elements in the list. So the increment operator is missing, so I added it. I think the flip variable should be capitalized. Now I am going to run the test cases. Okay, all the tests passed. Next, I am going to submit this program. Cool, it's accepted. Next, I am going to do the code walkthrough with sample input. Let me explain the code flow with this input. So we have this tree and the expected output is 5, 4, 1 and 3, 6. Okay. So initially the queue contains only the root node. So only it has 5, and then the flip variable boolean is set to false. We are entering the outer loop. The queue length is greater than 1. So we go ahead and initialize the current level list and then get the count. Then the inner for loop go over each node in that level. So in this case there is only one node. First element is dequeued and assigned to cur node, and then I added the cur node's val to the cur level list. Then I check whether there is a left and right child exist. If so, then the corresponding node will be added to the queue. So once all the elements processed, we come out of the inner for loop and then we check whether the flip is true. In this case flip is false, so we do not reverse it, we just use that cur level list as it is, and then we toggle the flip variable. So now it will become true, and then the cur level list will be added to the out list. So in the first iteration only node single list with value 5 is added to the out list. So in the next iteration the queue has 1 and 4 and the cur level list is initialized to empty and flip is right now true. So the out list currently has only one list with single element in it. So when we enter this loop we get the count as 2 and then cur level list is empty, and we enter the inner loop where we process each node. First we take node 1 and we add that value to the cur level list, and then we check whether there is a children, but there is no children for node 1. So we go for the next iteration where this node 4 is processed and that value is added to the cur level list. Then we check whether left and right child exists. Here it is. So these two nodes will be put in the queue. So that's what we are seeing here. At the end of this, the second iteration, the queue has 3, 6 and then the cur level list has 1, 4 and flip is true. So what we do? We reverse the cur level list. So this will become 4, 1. it will become 4 comma 1. Okay. 4 comma 1. So this list is reversed, and then the reversed list will be added to the out list. So we have 5 and then 4 comma 1 in a separate list. And then once that is done, we toggle that flip. So now the flip becomes false. So then in the next iteration, whatever the curl level list is generated, that will be used as it is. So for this case, we have 3 and 6 is in a queue. So then in the next iteration of the outer loop, we'll see number of elements in the queue is 2, and then we initialize the curl level list. Then we iterate over the nodes in that list, in that queue, and we dequeue that 3, and then we add that to the curl level list, and then we check whether there is a children, but no children here. Same thing for the node 6, there is no children. So only 3 and 6 added to the curl level list. Because flip is false, we will not reverse it, we will use that curl level list as it is. So that's why we are seeing 3 comma 6. So this is the expected output at the end. Next I'm going to do the time and space complexity analysis for this solution. I use this input for the time complexity analysis. So for this input, the tree will be like this, and on level 0 we traverse one node. On level 2 on level 0 we traverse one node. On level 1 we traverse two nodes. On level 2 we traverse two nodes. So totally we traverse 5 nodes. So it's all, we have to process all the nodes. So the time complexity is order of n. Now let's do the space complexity analysis. So the final out list needs to have the space for as many number of elements in the tree. So that is order of n. And if the in addition to that, we use space for holding the intermediate nodes, the curl level list. We need to allocate space for this. So this in addition to that, we need to allocate space for the queue. Okay, so tree with height 0, queue needs space for only one node. If this is the only one node, the height is 0, so we need space for one node. If the height is 1, there will be at maximum 2 nodes in this level, so we need maximum space for 2 nodes. On this level 2, if the tree is complete binary tree, the node 9 have left and right children, so totally 4. We cannot have more than 4. So tree with height 2, the queue needs space for 4 nodes. So if we extend that, the tree with the height h, queue needs space for 2 to the power h. Okay. So the h is nothing but log n for the complete binary tree. So the space needed, space complexity is order of n plus 2 to the power log n, which is approximately order of n. Thanks for watching this video. Have a great day.